So I look to integrate this problem, and I'm hoping that I can do partial fraction decomposition. And if so, I would try to factor. And as I look at this, things that add to 4 and multiply to 5. Oh, crap, this is a positive. So plus 5, x plus 1, that would be a plus 6. It's not going to work. What that means is partial fraction decomposition is not the right way to go. But that would be easier probably than what we're going to ultimately use, so I always try that. Instead, when I think about the integral of 1 over 1 plus x squared, well, that's arctan. What if I had 1 over 1 plus x plus 2 quantity squared or something? Well, that would also be arctan. This would be arctan of x plus c, and this would be arctan of x plus 2 plus c. And so I really need to complete the square. That is going to allow me to make this look like a perfect square and use arctangent. So let's think about what it would look like to complete the square here. So we're really trying to complete the square on what you see here. And so I'm going to set this equal to 0 arbitrarily just to get this to mathematically work. And for me to be able to complete the square, I really need to get rid of this plus 5 with a subtract 5 so that I have a spot to complete the square. So really what we have is we've just subtracted 5 from both sides so that I can come up with that perfect number in here. If I were to add 4, and really, of course, the shortcut is half of 4 is 2, and 2 squared is 4. What that means is x squared plus 4x plus 4 factors into the perfect square x plus 2 quantity squared. But we had an equal sign, and we need to maintain equality, and I added a 4 in here to make this a perfect square, so I have to add 4 here as well. So that means we're really looking at this perfect square equals 1. But we need to be equal to what we had in the beginning. So I'm going to subtract this 1 back so that I really have the integral of 1 over x squared plus 2, the quantity squared, minus 1. No, sorry, plus 1, because we added 1 on both sides. I was wondering why that wasn't working. Now it's working. This is the same as the original integral 1 over x squared plus 4x plus 5 dx. And this one we can see, well, this is really arctangent. It's arctangent of not x, though. It's arctangent of x plus 2. Let's clean this up. That shouldn't have been squared there. X plus 2 quantity squared. So then the answer will be arctangent of x plus 2 plus c.